So for the Muller's method, suppose we have a given function which has any degree, maybe x cubed or x to the fourth, aside from a quadratic equation which has a second degree function. So for any given function, you can formulate a formula using a parabola with 3 points. It can be x0, x1, and x2. So suppose a given function f of x of 0 is equal to a x0 minus x2 squared plus b x0 minus x2 plus c. So from 3 points, we can formulate an equation to become a quadratic equation. So this time, this is a quadratic equation which has a second degree. So f of x1, a x1 minus x2 squared plus b x0 minus x2 or x1 plus c. For f of x2, suppose that x2 will be cancelled out, so f of x2 will be equal to c. So we can use these formulas to formulate the slope of the function from x0 to x1. So this will be delta 0 f of x1 minus f of x of 0 over x1 minus x0. For delta 1, we can use the formula f of x2 minus f of x1 x2 minus x1. And h0, you can equate that to x1 minus x0. For h1, x2 minus x1. So find the value of a, b, and c, which c is already equal to f of x2. So a is equal to delta 1 minus delta 0 over h1 plus ho. For b is equal to ah1 plus delta 1. So for the first iteration, we will be using x0, x1, and x2. So using the Muller's method, we can find the next x, which will be equal to x3. So x3 is equal to x2 plus and minus negative 2c over b plus or minus square root of b squared minus 4ac. So for example, we have a given function x cubed minus 12x minus 11 is equal to 0. So initial guesses, x0, x1, x2 is equal to 4.5, 5.5, and 5. For the first iteration, first find f of x of 0. So 4.5 cube minus 12 times 4.5 minus 11. So this is equal to 26.125. For f of x1, f of x1, which is 5.5. 5.5 cube minus 12 times 5.5 minus 11 is equal to 89.375. So, for f of x2 is equal to 5 cube minus 12 times 5 minus 11 is equal to 54, which is also equal to C. So we have f of x of 0 is equal to 26.13, f of x1 is equal to 89.338, and f of x2 is equal to 54. So using the formula for Muller's method, we can find the delta 1. Delta 1 is equal to f of x1 minus f of x of 0, or delta 0 over x1 minus x0. So $89.38 minus 26.13 all over x0, 4.5, 5.5, and 5. So 5.5 minus 4.5 is 1. So we have 63.25. For delta 1, the formula f of x2 minus f of x1 all over x2 minus x1. So 54 minus 89.38 all over negative 0.5, which is x2 minus x1. So we have 70.76. So we can write delta 1, delta 0 is equal to 63.25, and delta 1 is equal to 70.76. So we have already delta 0 and delta 1. So find first the h of 0, which is x1 minus x0 is equal to 1. For h1, x2 minus x1 is negative 0.5. So we can find now the value of a. Value of a is delta 1 minus delta 0 over ho plus h1 is equal to 63.25, or 70 minus 76, 70.76 minus 63.25 all over 1 minus 0.5, 1 plus negative 0.5 is 0.5. So a is equal to 15.02. So we can find now the value of b. Value of b is AH1 plus delta 1, which is equal to 15.02 times the value of H1 is negative 0.5 plus delta 1. Delta 1 is 70.76 is equal to 63.25, which is also equal to delta 0. So we can find now the value of x3, which is the next x2 for the second iteration. So x, A is equal to 15.02 and B is equal to 63.25. So x3 is equal to x2 plus or minus negative 2c over b plus minus square root of b squared minus 4ac, which is a quadratic formula. The next to the value of x2 is 5 plus negative 2c, 54, or b f of x2 all over b, plus because the value of b is positive, so we will use positive for the formula of x3, b plus square root of b is 63.25 squared minus 4a, a is 15.02 times the value of c, which is 54. So the value now is 3.81. x3 is equal to 3.81. So for the first iteration, the value of x0, x1, and x2 is 4.5, 5.5, and 5 respectively. For the second iteration, we are now using x1, x2 is equal to, from 4.5, the x0 will move to 5.5. So 5.5, 5, and 3.81.